to remind ourselves that's all. My name is Trevor Branch, and I'm the organizer of the series, at least the parts that aren't completely done by Sherry, that is. And it gives me great pleasure today to have the 8th Bevan speaker of our series. And I'm going to hand over to Dr. Castell from the, not Dr. Craig Castell from the Alaska Fisheries Science Center to introduce our speaker.
Thank you. It is my honor and great pleasure today to introduce Dr. Steve Campana. He's from the Thetford Institute of Oceanography, the Marine Fish Division in Dartmouth, Nova Scotia. Make sure I get all that straight. He is the chief scientist in 2 different labs there. One is the Canadian Shark Research Laboratory, and the other is an otolith Research Laboratory. Steve's work spans just a huge, amazing amount of information and just range of topics. Beyond some basic fish otolith research for age determination, all kinds of otolith research for environmental parameters, environmental information from otolith. At the Shark Research Laboratory, I was looking over a list of publications that Steve has done, and it's mind-boggling. From basic biology and life history to reproduction, migration, growth, stock structure, fishery bycatch, gotta make sure I get them all here, and stock assessments. It's an impressive list. And then also just basic work on assessments, stock assessments for other important fish. Just the number of times I've been doing some age and growth studies and run into a problem or an issue has come up, and the first thing that always comes to my mind is, oh, I bet Steve has run into the same problem. Let me go get one of his papers and read up on that. And usually, sure enough, Steve got something figured out first and problem solved, and I use his ideas and go on with the work I'm doing. Just an example, a few years back, Steve did a key piece of research, some groundbreaking research, where he used bomb-produced radiocarbon. This is radiocarbon left over from the 1950s and 1960s from above-ground testing of atomic bombs as a time signal in the vertebrae of 2 large shark species in the Atlantic. This was key information, groundbreaking information, where these isotopes left over from, were produced by atomic bomb above-ground testing, used as a time signal. And it was the first time this was used in vertebrae in these large sharks. It was a real important piece of research, and now other folks are going on to do similar work. So today Steve is going to talk about using satellite pop-up tags on large sharks in the North Atlantic. This is to study their behavior and movements. So Steve?
Thank you very much, Craig. Welcome, everybody. Craig, I'll pick up my Visa card from you later for all the kind things you said for me. Welcome, everybody, to our version of Shark Week. I hope to leave you today with a little taste for some of the shark research that we're doing in Eastern Canada. A lot of the shark species that we work on are actually species that you have here in Washington State waters, so there will be a lot of parallels there. And I hope I also leave you with some appreciation for how little we know about these charismatic animals that are out in our oceans. Now, you probably have the same basic understanding of shark behavior and shark biology that I did, and you probably learned it from the very same source. This is, of course, from the movie Jaws, which followed the book Jaws by Peter Benchley in the 1970s. And that one piece of work galvanized the public reaction against sharks more so than any other single event in history. It was amazing. It took decades for the after effects of that movie and book to wear off. And as a matter of fact, it still happens. I mean, there are still people afraid to go swimming in the oceans because of this movie. And this is Hollywood, of course. Nevertheless, it's something that we're constantly battling to work against, because I hope to leave you with the thought that you're not in as much danger from sharks as sharks are in danger from you. That is, from humanity. So let me start with one of the sharks that's actually in the same family as the great white shark. This is the Porbeagle shark. It is a smaller relative of the great white. It is found in considerable numbers on the east coast of Canada, as well as in other world oceans. This is not one you have on your coast, but you do have a closely related one called the salmon shark. So, how do you identify the Porbeagle? Let's say you're swimming off the beach and you see a big shark fin coming towards you. What do? No, you don't get out of the water. You go and you look at the dorsal fin and you see it. And if there's a white patch on the dorsal fin, the trailing edge, it's a Porbeagle shark. And that's good, because the Porbeagle, despite its fearsome appearance, is strictly a fish and squid eater. Now, if you don't have a good view of the fin, then what you do is you wait until it gets a little closer. And the Porbeagle teeth are very characteristic. They have a big central cusp and then two little toothlets on either side. And it is diagnostic of Porbeagle shark. As a matter of fact, tooth morphology for many shark species is diagnostic. Now, on the other hand, if you see this type of appearance of tooth, you're pretty much toast. Now, the Porbeagle is interesting because it is actually the target of the only directed fishery for a large shark in Canadian waters, either coast. And a lot of that fishery is prosecuted by vessels such as this, which is a pelagic longline. So for those of you who are not familiar with these are vessels that set out a very long horizontal line, up to 50 kilometers, 30 miles long. Every 50 yards or so, there's a gangin or a leader hanging down with a baited hook. And this is set out at night, where it's soaked, and then the next morning, it's pulled up. And usually, the catch on these long lines is almost a pure catch of Porbeagle sharks. It's a fishery that's prosecuted about 100 yards down in the water, very often offshore, in relatively cool water, somewhere in the order of 40 to 50 degrees Fahrenheit. And it's an area where you simply don't have many other large animals that will bite on the hook. So from a fishery perspective, this is about as clean a fishery as you can get, which is good. And this is one of the sharks where they are using far more than just the fins. I'm sure you've all heard about the shark fin market. The fins are used here, but the meat itself is used. There's a big market actually over in Italy, believe it or not. And it's actually very good. If you've ever had the chance to have shark on the barbecue, Mako, for instance, the Porbeagle tastes very similar. As a matter of fact, it tastes so similar that the fishermen often call Porbeagle Faco, because they get more money for it if it's sold as Mako. Now, we've been working with the shark fishing industry for years now, in close cooperation, and we've been doing all sorts of, starting with the biological studies and then moving on to the population level. And it involves things like tagging studies on young of the year Porbeagle, such as this. And these things are released back into the water and recaptured years later, of course. But after years of that, we had enough information. We were able to put together a population level model for the Northwest Atlantic population. And this is basically the pattern we saw. The fishery itself started in 1961. So before 1961, there was essentially no fishery on Porbeagles in the Northwest Atlantic. And this is an unusual situation to actually have a measure of what the virgin population was like before fishing. And you can't really do that with things like Atlantic cod, for instance, where they've been fishing it for 300 years, or even salmon on this coast. This was all started by an enterprising Norwegian fisherman. He called up all his friends after he realized that the catch rates were great. In the space of only 6 years, they brought that fishery to the point of economic extinction. Not biological, of course, but economic. And for the next 30 years or so, things limped along, and here's where Canadians got involved, and you can see things went down again. Right around here, we got involved, and we were able to put together this population model, realize that things were being grossly overfished, cut the quota, the fishing quota, by 90%, close the mating area of fishing, and you know what? It seems to have worked. there's actually been a recovery of sorts, a little small recovery that is suggesting that this thing is increasing. So this level right here is roughly 1/4 of what the virgin level is. And that, according to CIWIC, the Canadian agency that recommends which species should be listed as endangered, was enough to rank this as endangered. But you know what? Most of our commercially fished stocks around the world are far less than 1/4 of virgin abundance. Nevertheless, this one is lower than where we want. Now, I was one of the key instigators of this population model, and so I have great reliance in this recovery rate here, and I know you do too. Yeah, that's what I thought. I don't have that much faith in it. So we needed a reality check. And our reality check was a fishery independent survey that we started in 2007, and we repeated again in 2009. And essentially what we did, this is the east coast of Canada, there's the US border right there. At each one of these stations, we fished a scientifically observed shark station. So this was all done aboard commercial shark fishing boats, but on each one of these vessels, I had one of my biologists, and all of these vessels were fishing identical methods, identical gear, identical bait, and identical time. So it was like having a regular research survey. And for each station that was fished, we typically caught Porbeagle sharks, as well as some others. And these were brought aboard very often in winches like this. The large females were satellite tagged and released, and I'll talk about this in a minute. We got all our measurements and weights, etc. And at the end of it all, we put it all together to get a synoptic view. And here's the picture we got in 2007 and again in 2009. Each one of these symbols is a fishing location. The size of the symbol is proportional to the catch at that location. And the color is a representation of the water temperature at the depth of the fishing gear, so down about 75 to 100 meters. I think you can see that the overall distribution pattern is pretty similar in the 2 years. They're mostly concentrated along the edge of the continental shelf, and these areas right here are deep basins. When you actually stratify these catch rates by the temperatures that are present, because we know the porbeagles won't go into very warm water or very cold water, the relative abundances here in the 2 years are almost identical. That's basically what we expected. The fishery for this has been at very low levels in recent years, largely because the market has dried up, because the fishing markets are requiring green label certification these days, things like MSC, Sea-Watch. And they don't have it for Porbeagle shark. So the fishing's down very low. We know these are unproductive sharks. These things are growing to be 30, 35, 40 years old. They only have 4 pups, and it takes them 9 months to have those 4 pups. So this is not like salmon or cod or halibut or anything like this. These are unproductive populations, and they can't handle much fishing. What this does is it sets baseline for us. So we can go back in 5 years' time or 10 years' time, repeat these same stations using the same scientific survey practices, and we will determine if that recovery is indeed taking place. And you know what? If it's not, I can guarantee you that fishery is going to close down. This is something that we're not going to take any chances with. Now, a couple of years ago, I started getting interesting phone calls from haddock fishermen on George's Bank. Now, George's Bank is right here. That's right near the Canada-US border. And it's a very popular ground fish ground, cod and haddock. But the thing is, they fish for haddock using bottom trawls. And bottom trawls are these large nets. They tow slowly along the bottom. And I mean slowly. I mean they're going about this speed. And these Porbeagle sharks are very fast fish. They're among the fastest fish in the ocean. And it's very unusual for them to be caught in bottom trawls. And yet I was getting reports of some of these haddock fishermen going out there and catching 5, 10, even 14 Porbeagles in a single trip, which is very unusual. Clearly something was happening there, and we needed to find out what. So we launched a small expedition where I went out on this long mining vessel. And if you note a resemblance here to the SS Minnow from Gilligan's Island, that's pretty much the way I thought of it too. But we headed up to George's Bank, we set the fishing gear, and man, did we catch sharks. All Porbeagles, all in great condition. Some of them were happy, some of them were less so. But we wished them in and put them on deck. And this is probably the most dangerous time to handle the sharks. When they're brought on, and especially when they haven't been on the hook very long, and therefore are still fresh, they get out there and they thrash all over the place. And it's a good time to be less of a hero and more just let them thrash out for a minute or so just to calm down. But once they do that, the first thing I'll do is put them on life support system. And the life support is 2 steps. The first step, which I haven't shown here, is I'll take a black cloth, wet, and I'll put it over the eyes. And it's amazing. Put it over their eyes, they can't see, calm right down. That makes a difference. But of course, the shark is a fish, right? It needs to put water over its gills. So the second step of the life support is to put a seawater hose in its mouth. I mean, all these commercial fishing boats have pumping seawater on there to wash off their deck. We just put it in there, the water goes in its mouth, out over the gills, gives them the oxygenated water they breathe. And it's amazing. So these sharks, especially if they've been on the books for hours and hours, they come up and they're very lethargic. I mean, some, if they're on there long enough, they'll die. But we'll put them on life support for 5 minutes, and it's as if there was never any problem. And so what it means is we can keep them on deck and do our measurements and our tagging, and we don't have to worry about them suffering or being in stress. So the big advantage of bringing these sharks up is to take advantage of a very recent technology which I call satellite tagging. And it's actually more properly called an archival satellite pop-up tag. So what we'll typically do is we'll either bring the shark up on deck, or in this case we'll use a cradle of some kind, and we'll insert the satellite tag into the dorsal musculature just underneath the dorsal fin. This is the satellite tag right here. About the size of my palm of my hand. It is basically a combination of sensors and a computer. And what it does is, about every 10 seconds or so, while it's attached to the shark, it's recording how deep the shark is in the water temperature down there, and then a very rough idea of location based on light. There's a little wire in here that can be programmed to burn off after a certain length of time. And we can program it to release up to a year in advance. And at that time that wire burns off, this unit here floats to the surface of the water, transmits all of the information that it's been collecting on the shark up to an Argos satellite, and back down to us. So we get all the information on what the shark's been doing without having to recapture the shark. Very cool. The only downside is these little units here are about $4,000 each. So you don't get as many of them as you want. There will be a can circulating, by the way. The other thing that was interesting about this particular fishing trip is that all of the sharks we caught there were large females. As a matter of fact, 2 of the females were record size, and we've examined thousands of Porbeagle sharks. To get all females, mature females, I've never heard of before. So clearly something was happening. We kept most of these sharks in great shape. We tagged and released them. We did open a couple to see if they were feeding on something, and they weren't. And you know what? Turns out that they were there for mating. What happens with Porbeagles and with many other shark species, the females move into the grounds first. The males will follow a couple weeks later. They will have their romantic interlude, and then they all separate. And this is what it was. So this is only the second known mating ground for a large pelagic shark anywhere in the world. So it was very exciting to find. So after we get the, oh, and you can see the satellite tag in here, by the way, and this shark is very much alive, I can assure you. So what we do is we winch it back in the water, it waves goodbye, and takes off. This is the big question we wanted to answer. Where do they go to give birth? We knew from our sampling of the commercial vessels that essentially all the females, mature females in September, are pregnant. And we also know that the pregnancy period is about 9 months. Actually very similar to a human female. Matter of fact, they become sexually mature at age 13, very much like a human female. And they have 4 pups, not quite so much like a human female. But we know where they're mating, we don't know where they go to give birth. So we started looking at where the pop-up tags were popping up to give us an idea of what was going on. So the way to interpret this, pink is female, green is male. The number refers to the month of the year when it popped up. So this would be February. This closed symbol is mature, and the open symbol is immature. So when we looked at the 21 tags that we put out on immature animals and things that were not programmed to pop up around the time of birth, we found that most of them were hanging around the continental shelf. A surprising proportion were going out into the high seas. These were of concern to us. The reason being, once you get outside 200-mile limit, and this applies as much to the U.S. as it does to Canada, it's like the wild, wild west out there. There are some international agencies that supposedly regulate the catches, but I can guarantee you that they are not well enforced. There's a lot of very bad things that happen up there. However, when we started looking at where the pop-ups went from the Georges Bank females, we found that they all went down to the Sargasso Sea. This is Cuba, down here, or there. This is a big surprise. I mean, the distance from here to Canada is about 2,000 kilometers, 1,300 miles. And you really have to wonder, why do they swim so far to give birth to a young porbeagle, which is about this size, and is a fully functional predator with very significant teeth? They go down there, give birth, and then a few months later, the females are back in Canadian waters. And you know what? The young of the year are back in Canadian waters a few months after that. So why do they bother swimming so far to give birth? Don't know. The other interesting thing is when we reconstructed the swimming tracks of these things. So this is satellite imagery of the Atlantic showing the pseudocolor for sea surface temperature. So red is very warm water, purple is very cold water. So when we reconstructed the swimming tracks of these porbeagles, we found that they were spending the summer and the fall in the coastal waters. And in late fall, they took off and they made a beeline for the Sargasso Sea. The thing is, when they left this cold water and encountered the Gulf Stream, they were faced with a problem. Because the porbeagles are cool water sharks. They're typically between 5 and 10 degrees Celsius. And that Gulf Stream water is somewhere between 20 and 30 degrees. Turns out, and when we saw the depth records from the satellite tags, they swam along, they hit the Gulf Stream, they literally swam underneath the Gulf Stream. It was very cool. Down to depths of 1.5 kilometers, 1,500 meters, which as far as I know is a record for a large planet. And then once they made it past the Gulf Stream, they stayed down at least half a kilometer below the surface while they were down here. Now, up until that time, there had never been a record, not even one, of a porbeagle further south than right there. And here it turns out this is the big birthing ground for it. And probably the only reason we discovered it was the satellite tags. Because there's no way fishing is going to get half a kilometer down. And that's good. This is a built-in conservation issue for the porbeagle. Because down here, half a kilometer down, they're not likely to be caught by fishing. And that, as I said, that's possible. How does this pop-up tag work? Well, I told you it's a sensor array and computer. There are the pressure sensors, which are depth, of course. There's the temperature sensor here. And then the big one is a light sensor. And the light sensor is here, right there. So the light sensor is what we use to get the location. How does that work? Well, if you look at what comes out of one of these tags, say if you put one of these tags in the ocean water, you'll often see a pattern like this. So this is light level, and this is time. And you'll see a daily pattern, as you might expect. So we get two pieces of information here. To get longitude, we look at the time it takes to go from one peak to the other, day length. Actually, for the one that we get first is the time of high noon. So just as you know, when you fly across time zones, this is all linked to an internal time, internal clock on the tag. And so we can get the longitude fairly accurately. Because to go from the center of there to the center of there can be done fairly accurately. But when you look at the day length, that's different. So here you're trying to go from the beginning of dawn to the dusk. And there's very often these shoulders in the data associated with, say, clouds being down on the horizon or something like this. And latitude, which is what day length is associated with, is far harder to estimate. So these satellite tags, they can give us a longitude good to about 50 to 100 kilometers. But the latitude, depending on the time of year, is usually worse. Now, interestingly, these satellite tags are now being released with a magnetometer. They're sensing the magnetic field in the Earth. And we're getting far more precise locations with that. So that's very exciting. The other thing that happens with this, when we reconstruct the pathway, we're able to link up with the temperature record that the tag is recording. So we can go to the satellite imagery. We know from the satellite tag when it's near the surface and get the temperature there, and we can link it up to the satellite imagery. And we know that certain parts on that particular day will have the right temperature and certain parts won't. So when it's all put into a state space model, that's when you get more accurate reconstructions of the fairly complex algorithm, and it's not very precise yet, but it is getting better. Okay, so let's move to a different shark. This is the mako shark, the short-fin mako, also found on your coast. Remember also the great white and the Porbeagle family. This, to my mind, is the scariest shark in the ocean. I think I would rather jump in the water beside a great white, beside a great white, rather than a mako. I would certainly do it with Porbeagle. You'd have to drive for a couple of meters. But a mako, not a chance. This is, to my mind, it's sort of like a psychotic shark. It gets on deck and it goes absolutely bananas. And it gets very large. This is a 1,200-pound individual, 12 feet long, that was caught rod and reel at a shark fishing tournament on Nova Scotia a couple of years ago. It looks surprisingly like a great white, eh? Apparently this thing was hooked. It didn't realize it was hooked. They managed to sort of reel it slowly inside the boat. They got a rope around its tail, and then it went crazy. And it was a good thing it was a 50-foot boat, because otherwise it wouldn't have survived it. Now this was a neat shark. This is one where, at these shark fishing tournaments, I have a team present at all of these tournaments to examine all of these sharks that are examined, and I happen to be at this one. And we always, because the sharks are dead by the time they come up, we always open them up and check sexual maturity and stomach contents. And this is one, given the size, that I remember thinking, just to myself, oh, please let there be a human arm or a leg in there. But there was nothing. This picture you will probably see circulating on the web, and it has become part of the urban mythology on the web. So this was the mako that was caught at the Yarmouth Shark Fishing Derby, and these two pictures are my pictures. You'll see them on the web now associated with being a West Coast great white shark, usually British Columbia, sometimes Washington State. And it's a great white that was caught, that pulled the boat backwards, almost sank the boat, and a whole story written around it, all totally false. It's very interesting. It's just totally false. Now we happen to be out fishing for blue sharks off Halifax, just a couple of miles offshore. I was putting satellite tags on, and as luck would have it, I had a film crew on board, and we hooked into a mako. So we're on rod and reel, and you're going to see it jump out of the water shortly. I don't know what it is about makos. They always seem to jump. That particular shark actually jumped a third time right beside the boat. And at that point, the skipper turned to me and he said, if he jumps again, he might land on the boat. And I said, yeah, if he does that, we're going out. And he agreed, and we weren't kidding, actually. So we fought that particular mako for 4.5 hours. We finally got it beside the boat to get a tag on. And at that point, I was able to measure it. It was 8.5 feet long. So I then went back to that video replay, and I measured how many body lengths out of the water it jumped. Turns out it jumped 14 feet. If I hadn't seen it, I wouldn't have believed it. But you know what? We've since caught other makos there, and they all jump. It seems to be a characteristic. These are very fast, very powerful animals. Okay, the next shark is the most common large shark in the ocean. This is the blue shark. Long and slinky, gets up to 13 feet long. Beautiful sharks. These are often the ones that the recreational shark fishermen will catch. So we have about a half dozen shark fishing tournaments or so every year in eastern Canada. It's the only time recreational shark fishermen are allowed to injure or kill the shark. All of the rest is catch and release fishing. So this is the one time of year when they bring it up and bring it in. And as I say, we have a team present to examine these sharks when they come in. And we feed all that information into a stock assessment. So we're collecting length and weight information, and then we'll open up the stomachs and examine stomach contents and sexual maturity. I don't know what it is. I always have grad students there to help at the derbies, and usually some volunteers and everything. And it's always the women that are in there, up to their elbows in blood and guts, and it's the guys that want to record the data so they can get their fingernails through. Anyways, this is a shark that causes us great grief, and not just us, all over the world. And it's mainly because it is the most common bycatch in large pelagic fisheries around the world. So off our coast, on average, for every swordfish that's caught, they catch 5 to 7 blue sharks. So it's actually more accurate to refer to it as a blue shark fishery with a swordfish bycatch. Now, the commercial fisherman, of course, is in a quandary. I mean, what they like high-value species like tunas and swordfish. And what they don't like is blue sharks that steal their bait, for which they often have to cut off the hook. And the hooks cost them $1 each. Give you an idea of the magnitude of this problem. I was talking to a sword fisherman just a couple of months ago. He went out to the edge of the shelf fishing swordfish. He put out 1,000 hooks at night, like he normally does. The next morning, he reeled in the line, and he had 900 blue sharks. And you know what? That's not even a record. The average catch out there is in the hundreds for every 1,000 hooks that he put out there. This is a huge bycatch problem. And as you can appreciate, the fishermen don't treat them particularly well. Where it becomes a problem is the fact that the blue shark in North American markets has no commercial value. They're not eaten. They are eaten in Europe, they're eaten in South America, but not in North America. As a result, when you look at the overall blue shark catch in the North Atlantic, and there's one population for the whole North Atlantic, typical annual catch is in the order of 30,000 tons a year or so. But from various sources, we know that the actual catch is well over 100,000 tons. And that means that the vast majority of these are discarded. They're thrown back. Most of them are thrown back alive. But the big issue is, do they actually survive? So what we did is we launched a study a few years ago. We went out on a number of these swordfish trips, and we took a random sample of the blue shark bycatch they caught it, brought a satellite tag into it, and released it again, and waited for the results to see if it lived or died. And the bottom line was that, roughly speaking, about 1/3 of these blue sharks are going to die at some step in the process. A small percentage of them on the hook when they're being caught. Another bunch are dying shortly after the release of the line. Now, 1/3 is a lot. There's no question. But you know what? It's actually not nearly as much as I expected when I first did the study. And the fact that it's only 1/3, given how badly they're treated by the commercial fishermen, probably explains why the blue shark population seems to be doing fairly well right now. It's hard to get a good handle on it. This is a population that spans the whole North Atlantic, many countries fishing it. They don't typically keep good records on bycatch species, especially going back many years. So it's hard to tell, but the official ICAT stock assessment suggests that they're in pretty good shape right now. We've also got some very useful, interesting information coming from the satellite tags as well. Each of these are showing the pop-up locations of these blue sharks that we tagged as part of the study. They've only been out 3 to 5 months or so. And you can see that they've scattered from, there's Nova Scotia where I am. They've scattered well in the Atlantic. Some have gone to the mid-Atlantic ridge, some down off of Cuba. I suspect if we had tagged them for 1 year later, a lot of them would have shown up off Europe and Africa. These are very highly migratory fishes. We also got some very interesting diving behavior from these things. So again, here we've got satellite imagery showing the Gulf Stream coming up. I'll show you here just a little cartoon of the typical track of these blue sharks as they come out. So spending their time in the coastal water, spending some time right around the fringes of the Gulf Stream, and then coming down and spending the winter here. Now when we look at the depth and temperature record that came out of the satellite tag from these, we get a very interesting pattern. So what we've got here is the surface of the water down to 800 meters. This is the day of tagging. This is when it actually popped up. The black line here is the diving record of the shark overlaid on the temperature field of the water. And what you can see is that the shark was swimming along here in the upper 20, 30 meters of water or so until it hit the Gulf Stream. I think you can tell the Gulf Stream by this very warm water here. And within a couple of days of hitting the Gulf Stream, it started this wild diving behavior. So every night spent up at the surface, every daytime down 600, 700, sometimes 1,000 meters down in the water, and back up the next night. And the interesting thing is, they did it almost every single day, and every single blue shark did it. It's the most amazing display of DL diving behavior I've ever heard of. And you really have to wonder why they're doing it. And the obvious thing, I guess, is that they're following their prey. I mean, we do know there's lots of squid in the Gulf Stream. We know the squid do vertically migrate. But the thing is, when you look at the light sensitivity of the blue shark eye, and the blue shark is a surface-dwelling shark, after about 300, 350 meters, it's dark enough that the shark is functionally blind. You can't see a thing. And sure, you know as well as I do, sharks have other senses, a great sense of smell, etc. Nevertheless, their predatory capabilities when they're down 600 meters must be very low. So we've devoted a fair bit of effort to this, and the bottom line seems to be, a combination of following their prey and also avoiding this very warm surface water. So if they spend their daytimes up here in the surface water where there's no food, they're cold-blooded animals, of course. They burn off all sorts of metabolic energy. So what they do, they seem to dive down to these cooler waters, and at least they get cooled down, they don't waste as much energy down. Okay, we went from large shark, let's go to a smaller shark. This is a spiny dogfish. Again, very common on this coast, very common on our coast. It is the most common shark in the world, by the way. There's about 1 billion of them around the world. We've, again, worked in conjunction with the commercial dog fishing industry. We had a 6-year cooperative program. We collected thousands of samples, and we really got a good handle on the biology of these things, the growth and the reproduction. The big issue with the dogfish, of course, is when the commercial fisherman catches one dogfish, he usually catches thousands of dogfish. And again, like the blue shark, most of them are just tossed over as discard. So our big interest was to get satellite tags into this, and again, estimate the discard mortality. Because what we're trying to do is put together a population model for the spiny dogfish in northwestern Atlantic, which does not exist at this point. So we started putting satellite tags on these spiny dogfish. Now you notice that the size of the tag here, compared to the size of the dogfish, might be pushing the bounds of what you can expect. Nevertheless, from a few of these tags, we got some excellent results. So here's a dogfish that was tagged up here in September. It went down and spent the winter somewhere in the Gulf of Maine, near the Canada-US border in deeper water, and then came back to within a few kilometers of its tagging site next year. So very useful information. However, there's a number of tags that simply didn't report, and I'm going to show you some real video footage of what happened to most of our tags on these dogfish. So these were programmed to report about a year later, and the tags did report a year later and reported that our dogfish had died about 6 hours after we tagged them and then just gone to the bottom of the ocean. So clearly, we didn't want to just kill dogfish, so we had to go to Plan B. And Plan B is a new form of satellite tag, and there's actually 2 manufacturers that make them. One of them we're using is the X tag, which is significantly smaller than the full-size pop-up satellite tag. And we put about a dozen of these X tags on spiny dogfish so far, and it's working like a charm. They're all surviving, we're getting great results. So we're very excited. This technology, I think, is set to explode. So right now, virtually all the large pelagics people in the world use these. The tags, I suspect, are going to get much smaller. There's people putting them on eels right now, putting them on salmon. The smaller they get, the more fishes they can be put on. And the results you can get are amazing. Okay, we move from very small sharks. Let's move to the very big ones. This is a very common sight in summer and fall months off of Atlantic Canada. 2 shark fins separated by a very long distance. I get probably more phone calls about this in late summer than any other species, usually from sailors who are sailing along and they see sharks swimming beside their boat that's longer than their boat. So they phone me up and say, "Oh my God, there's a great white shark in our waters." It's not a great white shark. It is a basking shark. And the basking sharks are the gentle giants of the shark world, along with the whale sharks, I guess. These are huge animals. They're typically in the order of 25 to 30 feet long. And they are filter feeders. So they swim along the surface of the water, straining out zooplankton. They have essentially no teeth. They're very often near the surface, so that's why people see their fins sticking out of the water. And as a matter of fact, in general, if you see shark fins sticking out of the water in Atlantic Canada in summer, fall, it's usually a basking shark. Most of the other sharks actually don't do it there. You do have basking sharks on this coast that become very rare. They're in danger of extinction, as far as I can tell. And these sharks, they have their gills all swollen up as they're filter feeding through the water. We've managed to get 1 satellite tag on this. It was tagged off of in a deep basin off Halifax. A few months later, it popped up east of Bermuda. When you look at the depth record, this is 0 to 1,200 meters, you can see that it's averaging about half a kilometer down, but some of the depths are going down to about 1,100 meters or So this one shark, in the space of a few months, went down here. We had no idea where these basking sharks overwintered. Nobody did. And around the same time, my colleague in the northeastern U.S., Greg Scommel, he managed to get about a dozen pop-up tags on basking sharks there. And they popped up in the wintertime off of Brazil. Who would have known? Unbelievable. And this, I think, highlights one of the basic conundrums here. You have the second largest fish in the world, but we had no idea where it spent the winter. Do you know how many observations of pregnant basking sharks that we have all around the world, all studies combined? One. That's it. How can we know so little about a huge animal like this? It's phenomenal. What's also phenomenal, perhaps, and perhaps not so exciting for the general public, but for me as a scientist, is some of the deep sea expeditions that we're doing now, where we're getting our first look at some of the, I think, abundant deep sea sharks that are out there that we have no clue about. So we've had a number of high definition underwater cameras deployed in the last couple of years. This is one of a black dogfish down at 1,100 meters. That is, I think, the first video that's ever been recorded of this particular species of shark. And then perhaps more exciting, this is a deep sea cat shark, almost 2 kilometers below the surface. You are actually among the first members of the general public anywhere in the world to see a deep sea cat shark swimming. It's very cool. You know, a lot of the fish identification books right now, they have drawings of this. This is how rare they are. And we just captured it there. So this, as a scientist, makes me really excited. Sad, doesn't it? All right, to close this off, let me take you on a little story. This is an island off the coast of Nova Scotia known as Sable Island. And you may have heard about it. Sable Island is a giant sandbar. It's well known for the Sable Island ponies. It's also famous for a very large and growing gray seal population. And the gray seal population now there is on the order of 1/3 seals. And this is something that's been implicated in keeping the recovery of Atlantic cod in our coast down. Now what's interesting is you go along the beach of Sable Island and at certain times of the year you will see these carcasses of young gray seals, and that's actually less than a year old, believe it or not, despite the size. And these things are, in the summertime, it's fairly sporadic. In the wintertime, we will see as many as 900 of them along the beach. And they're all damaged in the same way. It's like somebody took a scalpel and made a spiral cut around the seal. And it's a very unusual mark. We've ruled out boats, largely because of the time of year. We've ruled out attacks by other seals. We've ruled out virtually everything can be done. But one thing we haven't been able to rule out, and we're pointing our finger at right now, is the Greenland shark. This seems to be our candidate. The Greenland shark is very similar to the sleeper shark that you have here on this coast. It's a very odd-looking shark, as you can tell. We have a very unusual group of them in the Gulf of St. Lawrence near the Saguenay Fjord that for about 3 weeks every year will come up within scuba diving range. And people in the last few years have realized this and become an ecotourism observation to dive with these sharks. Again, we know almost nothing about these sharks. Nobody's been hurt yet. They're very odd. They're very slow-moving and lethargic, and they can lull you into a sense of well-being. But we did have, one of the Chris Harvey Clark, who's done a lot of work with these sharks. He had a very aggressive encounter just a little while ago with them. So I think it's only a matter of time. Now, we had a deep-sea submersible a few years ago near Sable Island. We know that those things are present there. This is a video that this submersible captured. It was looking at the sea bottom off of Sable Island. That's an 11-foot Greenland shark. Since that time, I've seen video that was captured deep down in the oil rigs in the Gulf of Mexico, clearly showing Greenland sharks swimming along. These are cold water sharks. They don't like water more than 4 degrees Celsius. But the deep water, of course, is very cold all over the world. I suspect these things are all over, and we just have no idea. Nevertheless, we've realized that one of the best places to study Greenland sharks is up in the Arctic. They like cold water. We know they're there. So we launched an expedition about 2 years ago to get a handle on these Greenland sharks and get some satellite tests on them. And that involved flying up to a place called Iqaluit in Nunavut of northern Canada. 300 miles north of that is a place called Pangerton. We got on our ski-doos and we traveled for 3 hours at high speed. So we were 30 kilometers offshore on the sea ice. And there we set up a luxury camp. Now these are not just any plywood huts on skis. Okay, these have real tarpaulins on them. There's no heat. So this is where we lived for 2 weeks with no heat. And we did have a little Coleman stove that we could use to cook our food in, which is very comforting. So what we did is we fished through the ice. So our Inuit guide had a gas-powered ice auger. We would use this to drill holes all around the ice, and that wouldn't take more than about 5 minutes or so. But then you'd be left with a chunk of ice in the middle that weighed roughly a ton or so. So we'd spend the next 3 hours with ice picks trying to break it up enough to get the ice out. But once we did, we'd have a fishing pole. And what the Inuit do is they fish for a species known as Greenland halibut, or turbot, through that. And this is what they catch here. The thing is, usually when they fish them, every few hooks they'll pull it up and the hook will be missing. Or, on odd occasions, they'll pull it up and they'll have a big Greenland shark on there, which has eaten the Greenland halibut that's bitten the hook. But, of course, these things have teeth, so usually they didn't catch them. What we did is we brought up modern shark fishing gear, which is basically steel ganges, so they can't bite through it. And when we did that, we started catching Greenland sharks. And these are very weird animals. We would pull them up, and even though we had just hooked them, it was like they were dead. They were so lethargic. You'd pull them up, and you'd have to watch for minutes just to see the gills moving. And it's the way that they always are. These were big animals. They averaged 8 to 10 feet or so. They weighed, on the order of 600 pounds. We quickly realized that 3 grown men trying to pull them out on the ice wasn't going to work. So we adopted modern technology and pulled them out there. And then we would get our measurements and our examinations. This shark is fully alive and very healthy. We found that we could leave them there and they would be absolutely fine for hours on end. We didn't usually do that ourselves, but the Inuit often caught them. They don't like them. I mean, the flesh on these is poisonous. You can't eat them. They interfered with their turbot fishery, so they'd pull them on the ice and leave them. And sometimes they'd radio us, and we'd go and get on the ski-doos and travel hours to get there. And by that time, some of these sharks had been out there for 6 hours, and they were still very alive and very healthy. It was amazing. I guess cold temperature helps keep them that way. What we were interested in doing, of course, was getting satellite tags in. So we get the tag in, we push it back in the water, and we watch it sort of slowly swim away. And then we go and we settle into our luxury cabins for night. So the average temperature at night was 35 below. And, I'm quite an outdoor enthusiast. I camp a lot, but I've never camped in anything like that before. So I thought I was going to die. But it's amazing. If you have the right equipment, you're fine. So, you wear a survival suit in the daytime, you're fine. You wear a double sleeping bag at night, one of which covers your face. You're fine. It was really cool. Really cool. Now, the last 3 days we were there, we had a film crew come and join us from the show Dirty Jobs, so Discovery Channel. And these guys were all from California. In the preparation for this trip, I tried to emphasize it. This is really cold weather, okay? You have to wear survival gear. And they showed up with their puffy down jackets and their hiking boots and heavy-duty mitts. We met them at the Pangerton airport, and my Inuit guide that was with me took one look at them and turned to me and said, "They're all going to die!" So we had to go and buy them all sort of new survival suits and everything, and took them out, and they just froze to death. But you know what? True professionals, I give them full credit. They never complained once, and they got some good footage. So what did we get? Well, this is where we were doing the tagging in Cumberland Sound and Baffin Island. The arrowheads show where each of these Greenland sharks that we tagged went. That distance there is 1,800 kilometers. So first of all, we found that all these tags that we kept, or all these sharks that we kept on the ice, indeed were very healthy because they swam a long way in just a few months. And secondly, they might be swimming very slowly, but boy, they must have been swimming steadily because they went a long ways. They went a minimum of a couple hundred kilometers to get out there. We also managed to tag a few sharks off of eastern Canada. And they all went, on the average, 800 kilometers. Now, you'll notice that these points right here are all out in the open ocean. These are well off the continental shelf. So when we looked at the depth and the temperature records that went with these, we got an interesting pattern. So here's one from a representative Greenland shark. This is the day we applied the tag. This is when it popped up. These are bubble plots. So the size of the bubble at a given depth shows the proportion of time they spent at that depth. So in the early days, you can see it moved up and down between 300 and 800 meters. Here, it was just down around 800 meters. So that's all very good. Clearly, it's swimming along the bottom around, most of the time, around 800 meters, until you realize that the water depth where they are is 5,000 meters. They're nowhere near the bottom. So these Greenland sharks are swimming out there in the open ocean, 4 kilometers above the bottom, almost a kilometer down, doing what? No idea. You know, is there a subsurface layer of large fish that they're sort of munching along at the buffet table as they go along? Maybe. Are they going out there to meet? Maybe. Again, this is a shark that we catch up to 20 feet long off our coast. They are as big as great white sharks, and we know nothing about them. And even in terms of simple things like how fast do they grow, how long do they live, we don't have a clue. Unlike most other fishes, there are usually growth bands, like the rings on a tree, we can determine the age. And the vertebrae of Greenland sharks, you can take a butter knife and cut through it. There's no markings at all. So there's some people that say that they get up to 400 years old. And there's nobody who can disprove it at this point. There's been one study to try and estimate the growth of the Greenland shark. It was done in the 1950s off Greenland. They managed to get a tag into a full-size, 10-foot-long Greenland shark, and it got recaptured a year later. And during that time, it had grown 1 centimeter. So what they did, and I don't recommend this, is they extrapolate. They say, oh, so 1 centimeter here, 10 feet long, it must be hundreds of years old. Of course, you can't do that. But right now, there's no other information. So one of the big conundrums. So what's the bottom line then? Well, I don't think I need to tell you. I mean, sharks play a key role in the ecosystem. Not all the sharks, but a lot of them are the apex predators, king of the food web. They're like the lions of the Serengeti in Africa. Places in the world that have fished out all their large sharks, weird things happen in their ecosystem. Undesirable things, often unpredictable things. Usually not as predictable as just saying, oh, large sharks eat these smaller fish will become more. It's not that simple. Secondly, all around the world, a lot of these populations are endangered class. I mean, the great whites, even though great white sharks are now protected in many areas of the world, including in the US and in Canada, it's possible that in your lifetime, they are going to go extinct. That would be horrible. So this is something that's a real problem. And although I'm biased here, I think research really is the key to understanding and protecting them. And I can point to the Porbeagle shark in our waters as an example of that. That's one that is recovering because of the science. And you can start to do things when you understand what's driving it. And believe it or not, in some parts of the world, the shark fishing industry has helped with the research. That's the case in our area. That's certainly not the case in other areas. There are still some countries in the world, particularly some countries in Asia, that are going out there and doing the finning. The idea is they're catching the sharks, they cut the fins off, which are very valuable, they throw the still living carcass back in the water, and they let it die there. There's no excuse for that. There's no reason for that. And this is helping lead to the decline around the world. But you know what? It's no longer the biggest problem. The biggest problem is the bycatch. The accidental capture of these sharks, many sharks in fisheries where they're trying to catch things like swordfish and tuna. And the fishermen don't want to catch them, and they're not finning the sharks. But a lot of these sharks are dying, and they're just not productive. And certainly in Canada, and I think it's fair to say in the United States as well, and in particular the public are unwilling to let these sharks go the way of some of the other things that have collapsed over the years. So this is something we're keeping an eye on, and certainly in our lab, conservation is a big issue as well as research. Thank you very much. Be happy to answer any questions. Yes, sir.
You said already you don't know the answer, but can you imagine reasons the female porbeagles would go to tuna to pup? at depth?
You know, it was originally suggested, oh, you know, Sargasso Sea is famous because the eels go there to spawn. Maybe the porbeagles are going there to feed on eels, or in particular, maybe the young of the year get to feed on eels while they're there. And my initial reaction to that was to poo-poo it. However, just in the recent past, I've been talking with a number of my colleagues that have been putting satellite tags on eels off a different part of eastern Canada, and they've been having some of their eels predated upon by something which, based on the temperature records and the depth records, may be Porbeagle sharks. So if that's the case, it may suggest that the porbeagles have actually adapted to feed on these eels wherever they are, and that they're going there as a major food source. It still seems a bit of a stretch for them, because these porbeagles, even at that size, are fully functional predators, and there's lots of small fish around. But, you know what, that's about the only thing I can come up with so far. Yes?
I actually have two questions. One, do makos jump when they're not spawning? Like when they haven't been caught, do they actually jump?
To my knowledge, they are usually hooked when they're jumping, and it's probably an escape mechanism on their part. They're certainly capable of jumping when they're not hooked, that's for sure. But I haven't seen any video that suggests that they will do it otherwise, I guess.
Okay. And then I recently read a research article that evaluated the use of nylon cables for walleye fisheries as opposed to the steel cables, and that showed to greatly reduce bycatch. Has that been evaluated?
Indirectly. You know, it's a bit of a misleading thing. Yes, you can put monofilament gangins on there that the sharks can bite through, but you know, the sharks are still biting on the hook. They're still getting the hook in there. So what it means is that, yes, they're going to get off the main line, but they're going to swim around with a hook in its mouth. Now, the sharks do seem very resistant to that. I mean, we recapture blue sharks that will have 4 rusted hooks in its mouth. Sometimes we see swallowed hooks, and the shark is totally fine. Nevertheless, I think the preferable option is to make sure they don't get hooked in the first place. And, you know, things are being explored that like magnetic fields around hooks, which is generally not being very successful, but people are looking. It's a tough one. Yes?
It was like the third slide or so, showing the Porbeagle estimates from the beginning of the fishery in 1961, like 800 down to 200 now. You didn't say multiply by 1,000 or anything? Or
yeah, so that was all relative scale. So that's actually in thousands of individuals. So the current population estimate is around 220,000 or so. So it started at 800,000.
And so it's relative because you don't have absolute numbers, but you can say at least it's a quarter.
Well, actually, those were absolute numbers, but I just didn't put the thousand scale. So, yeah, so we're roughly 250,000. And you know, it sounds like a lot, but that's a big ocean off there, so it actually doesn't add up to very much. Yes.
A question kind of about the process of the science here. You showed us the Porbeagle, which was a direct fishery, the blue sharks, which interact with other fisheries, and some other sharks that were just kind of interesting. In your process, and in your labs, how do you decide where to allocate the next one of these $4,000 tags? How do you decide, well, here's something that we can make policy about versus this is just interesting?
Okay, fair enough. For the satellite tag money in particular, it often comes as part of a pot which is directed at the commercially fished species. So, for instance, I have another, I think 200,000 coming this year to put on more on porbeagles to get discard mortality and on makos, first time ever. So those are both fished commercially. They're not major fisheries in Canada anymore, but nevertheless they have commercial importance. What I will do, and I will not say this on the record, but I mean some of that money mysteriously, or the tags get mysteriously redirected to other species that I think perhaps might be of conservation concern. And I do get other pots of money which I will put on things where either the scientific curiosity is there because, say in the case of the deep sea sharks, or in the case where I am concerned about their conservation issues. And so it's a value judgment. There's only a small group of us there, so we make do with what we've got. But our plan is to eventually address all of the sharks in our waters. Right at the back?
Yeah, related to that, taking the example of dogfish, you mentioned putting them out as a way of trying to estimate discard mortality for them. Have you, or anybody done power analysis to figure out maybe how many tags are necessary to get some estimate of that and how much it costs? And whether that's feasible for kind of large-scale use?
Good question. No, I'm not aware of that. Just based on the small number we put out and got results from, say, a dozen, we're finding that the vast majority of them are making a transboundary migration and coming back. So based on that, we've already got our power analysis in a way already. We're getting an idea that this migration is not the exception, it's the rule. Where we wanted to roll it in is in a population model for the dogfish. And it looks like we may have, just in the last week or so, hit a bit of a stumbling block. We've been working on that population model for 2 years, and our last efforts of fitting the model have not been so successful. And so we're thinking that we might have to go back to the drawing table. So maybe we'll go back to the drawing table with these improved estimates of migration that come into it. But it is frustrating. I mean, spiny dogfish is one of the species that CITES has been considering listing as being protected under Appendix 2 of their international treaty. Porbeagle was another one, by the way. So this is one that's of great interest to everybody. You would think with 200 million in the Canadian waters alone, in Atlantic Canada, that we'd have some idea of what the health of the population is, and we don't.
I have a question about the Marine Stewardship Council. They just certified I'm sure you knew this was going to come up, but they just certified the swordfish fishery that has the staggering bycatch of sharks. So, is that something you agree with, or you think is crazy?
Crazy comes pretty close to it. I work very well with the sword fishermen, and a lot of the individual fishermen are actually very ethical. They're concerned about it, and they don't want to catch these blue sharks. And I also work very closely with the NGOs, the environmental agencies, and they're obviously very concerned. So it's hard for the NGOs and myself, I guess, to rationalize the MSC decision. The swordfish industry obviously is delighted. And nevertheless, I think it's fair to say they're not going to take it as a green light to just go ahead and keep doing things as they want. So they recently funded a study to examine the effect of these magnetic deterrents, which failed. But you know what? At least the swordfishing industry was trying to do it, and they weren't ordered to do it. So, you try and look at the bright light there, but MSC is increasingly, I'm finding it hard to rationalize some of the decisions. That's a personal opinion.
See, when it comes to age determination, do you get the opportunity to get enough samples throughout the year to age sharks from our Porbeagle on a regular basis? When you do age them, do you age the structure of the whole thin section? Do you stay in die?
The advantage of working with the commercial industry is that we have access to their boats. We can go and get lots of samples. So for things like Porbeagle and Spiny Dogfish and Rico, yeah, we have no shortage of samples. Our routine procedure is to take chunks of the vertebrae, prepare a transverse section, and use image analysis to enhance it without any dyes or stains. And for the vast majority of sharks, we get an excellent age reading. And we've been able to validate these, confirm the accuracy using various methods. Spiny Dogfish have a spine. They have bands on them. You can see with your naked eye. We've confirmed that those are accurate. Things like Greenland Shark have nothing, and they live forever.
You just mentioned that the study's looking at the electromagnetic field failed. Are you including some of what Steve Campana is doing? Because I noticed a few years ago they had really good negative responses to the E-fields and different metals that they're using. So not actually fabricating the hook out of that metal, but just suspending a chunk of that with the bait. Yeah. Is that the one you're referring to?
I don't know the specific study. There's been a few now. And okay. You know what? The magnetic field does seem to affect certain species in certain situations. Yeah. And I haven't seen a consistent response. So a couple of these studies have sort of looked at some of the same species. One study will report it worked, and another study will say it won't. And then the study that I talked about that was done off our coast, they actually had a design in which every second hook had the magnetic field on it, and then one without. And they actually found the magnetic field had a higher catch rate of sharks than the others. So it's hard to rationalize what's going on. I mean, certainly some sharks you would expect to have a better electromagnetic capability. The ones that get their prey off the bottom, you would expect to have more finely acute electroreception capability. But I haven't seen a pattern there. So I'm not sure. I haven't been doing those studies myself, but from what I've been reading and talking to people involved, at this point there's no consistent pattern to point to. But people haven't given up yet. I still more studies to come on.
Time for one more question, and then we'll have an after reception.
I just had a question about the satellite tracking method. You said the sensor uses light to infer geographic position. Does that get more difficult to do when the sharks are swimming at 1,000 meters and the light is attenuated? How do you account for that?
Yeah, more difficult, it would be an understatement. It becomes impossible. So for things like the Greenland Sharks, which were down 800 meters, the light levels were totally uninformative. So we've actually been working with the oceanographers at the Bedford Institute, and they actually have deep sea temperature fields that can be used to roughly triangulate where things are, but at very large spatial scales. What's proving to be more informative right now, we're beta testing a new type of satellite tag that's got this magnetometer. And when we couple that with the temperature field, we're finding we can, in some cases, pinpoint it fairly accurately, even in deep sea conditions. But you're absolutely right. If the light's there, especially if they're in waters deeper than, say, 150 meters, waste of time.
Well, it's been an absolute pleasure to listen to you talk tonight. Thanks very much, and please join us afterwards. There are some drinks and food outside, and